See second problem. What we have statement of the second problem. Find the angle between the normals to the surface xy is equals to z square at the points 4, 1, 2 and 3, 3, minus 3. So in the previous problem, what is the statement of the previous problem? So see here, this one, find the angle between the surfaces, these two surfaces at single point here. They given here equations, means two surface equations, one single point. In the present problem, what they given here? Angle between the normals to the surface. I said in the note, angle between the surfaces, that is always equals to the angle between their normals. Angle between their normals means angle between the del phi 1 and del phi 2. Here we need to find the angle between the normals. Both are same here. The formula is same for a angle between the surfaces is always equals to the angle between their normals. But in the present problem, what they given here? Only one surface equation, but there are 2 points. Okay, so we have to find the surface equation, means del phi 1 value at the first point and del phi value at the second point. So del phi value at the first point, consider that one as a del phi 1. Similarly, del phi value at the second point, consider that one as a del phi 2. Okay, so here what they given here, write it here. Given is equals to phi is equals to xy is equals to z square. Phi, what we have here, xy is equals to z square. Write this in the form of a phi of x comma y comma z is equals to c. It is not in the form of a phi of x y z is equals to c. Let us bring this form to the this one. Then this implies phi is equals to xy minus z square. Phi is equals to xy minus z square. So here find here del phi. Del phi value means apply a formula dou phi by dou x into I, dou phi by dou y into j plus dou phi by dou z into k. This is the definition of the gradient of a phi. We need a del phi here. So substitute here del phi, phi value. Phi means xy minus z square into I, dou by dou y into phi value xy minus z square into j, phi value xy minus z square with respect to z into k. So first term with respect to x is that, then we have to consider y and z as a constant here. So xy differentiation with respect to x partially, then it becomes y into I plus dou by dou y of a first term becomes x. X is a constant, z is also constant, z square totally constant, therefore 0, that then it becomes x into j plus this whole term with respect to z. X and y are a constant, this term becomes 0, differentiation of a first term 0, minus z square differentiation with respect to z means minus 2z into k. So write down in a simplest form, y into I plus x into j plus into minus 2z into k. So find here del phi value. See, this is our required del phi, na? So they given here 2 points. Okay, so find this del phi value, find this del phi value at the first point. Similarly, find del phi value at the second point. What we have first point here? 4, 1, 2. So these are the coordinates of x, y, z. So wherever is x, y, z in a function del phi, substitute 4, 1, 2 respectively. Y value 1 is there, 1 into I. X value 4 into j, z value 2 into k. Then it becomes I plus 4j minus 4k. Okay, consider this one as a del phi 1. Say it as a del phi. Okay, similarly, del phi value at the second point. What we have second point here? 3, 3, minus 3, na? So 3, 3, minus 3. Consider this one as the coordinates of a x, y, z. Wherever is x, y, z in this equation, del phi equation, substitute 3, 3, minus 3 respectively. Y value 3 into I, x value 3 into j, minus 2 into z value, minus 3 into k. Simplify this one. 3i plus 3j plus 6k. Consider this one as a del phi 2. Okay, you consider this one as a del phi 2. Next.